Hello everyone. How are you today? I hope everybody is okay and doing great at their home. By the way, my name is ahrby-sensei, and for today, I am going to introduce a new topic in grade 9 science. Okay, so for today, we are going to discuss mole concept, counting by weighing. So let's find out what does it mean. So this lesson is based on the 11th most essential learning competency, which is the use of mole concept to express the mass of substances. So at the end of this lesson, you should be able to convert the number of moles to the equivalent amount in the number of particles and compute for the molar masses of common substances. Now, if I'm going to ask you what is a mole, okay, are you going to give me an answer about the part of the body which is usually a skin outgrowth or an animal that lives on the ground? Yes, they are both called a mole, but the mole we are referring in this lesson is definitely not these things. Okay, so what does it mean? But before that, let us play a short game. Let's count the following objects, okay, given in each picture. So the first image is roses. How many roses do we have here? Yes, very good. We have 12. How about on the next image? Yes, very good. We have 12 eggs. And for the third image, yes, very good. We have 12 donuts. Now, what have you noticed with our images? Yes, very good. They have the same number of objects. Now, what counting unit is usually used to pertain 12 objects? Okay, clue. It starts with letter D. Yes, very good. You got it right. That is dozen. Okay, so 1 dozen is equal to 12 objects. Okay, how about this one? Okay, can you give me how many objects are present in this image and the counting unit we usually use for this? Yes, very good. One pair or two objects, right? So as you can see in the picture, we have two shoes or one pair of shoe. Next, okay, we have, very good, we have 52 cards or one deck of cards. How about this one? Okay, I think this is not commonly used to us, but maybe you know the answer. Yes, very good. You got it right. One gross or 12 dozen, which is equal to 144 pencils in total. Okay, so how about this one? So this is a bond paper. Okay, these are bond papers. So yes, very good. We have one stream of bond paper or 500 sheets of paper. How about this one? Okay, so we have one case or 24 cans of soft drinks. So among the examples I give to you, what have you noticed? Yes, there is a counting unit used to specify the number of items. Like for instance, my first example, 1 dozen of anything is equal to 12 entities or units. So no matter what object I use dozen with, that will always be 12 pieces. So for example, 1 dozen of eggs is equal to 12 eggs. 1 dozen of papayas is equal to 12 papayas. 1 dozen of cars is equal to 12 cars. 1 dozen of books is equal to 12 books. So because we have a counting unit, we will know how many items do we have in that specific object. Okay? A counting unit, as I said, states a specific number of items like the following. So, one pair of shoes is equal to two shoes. One ream of paper, 500 sheets. One case, 24 cans. One gloss of pencil, 144 pencil. One deck of cards is equal to 52 cards. So, as you can see, counting units are very important in counting common objects that we use every day. But here is my question. How about objects that are very small or at the molecular level or those that are microscopic? What counting unit are we going to use? So, and that is, okay, starts with letter M. We have now the mole. Okay, mole in chemistry is a way of counting. Mole is abbreviated as MOL. In fact, mole is the SI unit for the amount of substance. Like for meters, it is the standard unit for length. Okay, so 1 mole is always equal to, okay, repeat after me, 6.02 times 10 to the 23 entities. So this is how big 1 mole is. Now, when we say entities in chemistry, what does it mean? So the entities in chemistry refers to particles. And these particles can be atoms, like for example, helium atom, molecules, like for example, nitrogen gas and ammonia, and ions or formula units, like in case for sodium chloride that has formula units and can have ions such as sodium ion and chlorine ion. Now, every 1 mole is comprised of 6.02 times 10 to the 23 entities. And this is what chemists like to count or determine how many they are in a substance. Now, how big is 6.02 times 10 to the 23? Okay, so it's like writing 602. Okay, so let me write it first. It's like writing 602. Okay, sorry for my bad penmanship. With 21 zeros. So 1, 2, 3, okay, 4, 5, 6, 7, okay, 7, 8, 9, 10, okay, 11, 12, okay, 13, 14, 15. Okay, we're almost there. 16, 17, 18. Okay, 19, 20, and 21. Okay, so that is how big 1 mole is. So it is actually read as 602 hexillion. Okay, it's more than trillion, I think. Okay, now where does it came from? It was the result of Amedeo Avogadro's work on studies about counting atoms and molecules. He was born in 1776 and died in 1856. He was an Italian lawyer and physicist. So, in tribute to him, The value 6.02 times 10 to the 23 is now known as Avogadro's number, denoted by capital N and a subscript A. So, what is the basis for this very huge number? It was based on the number of atoms in exactly 12 grams of carbon-12. So what does it mean? Okay, so the scientists used a very sophisticated method in order to determine this value. They weighed 12, okay, so they weighed 12 grams of carbon and were able to determine that in 12 grams of carbon, we have 6.02 times 10 to the 23 carbon atoms. So this was the basis for the mole. Okay? So when I say 1 mole of hydrogen atom, how many particles do you think does it have? Very good. So 6.02 times 10 to the 23 hydrogen atoms. How about 1 mole of water molecule? Yes, very good. It is equal to Avogadro's number. How about 1 mole of sodium ion? Yes, very good. It is also equal to 6.02 times 10 to the 23 sodium ions. How about 1 mole of sodium chloride or NaCl? Yes, it is also equal to Avogadro's number of NaCl formula units. So, you can now conclude that in any 1 mole of substance, you have 6.02 times 10 to the 23 particles. Okay, so always remember this relationship because this will be useful whenever we compute for different problems involving mole concept. Okay, but that will be on the later part of our lesson. So now, for you to visualize how much 1 mole actually is. So these are some common chemicals found inside the laboratory. So we have sulfur, we have sulfur. So let me have my laser. Okay, we have iron, we have sodium chloride, we have this one, and we have this table sugar. Okay, so it's very important to have a counting unit so that the amount of substance is properly expressed in its standard unit. Okay? How are we going to visualize a mole? Because as I presented a while ago, 1 mole is a very big number. Imagine 21 zeros after 602. Okay, let me give you an example. So, if we are going to cover the earth with marble, okay, that marble can cover the entire earth to a height of 80 kilometers. So that's how big 1 mole is. So are you familiar with Philippine Arena? If we are going to compare 1 mole of sand to Philippine Arena and build a structure from it, okay, this is how it will look like. So a mole of sand will dwarf Philippine Arena. Because I think Philippine Arena is only 65 meters in height. And this mole of sand, if we're going to build a cube, would be 4,500 meters in height. Okay, so you can now visualize how really large mole is. Another for you to visualize mole. So a mole of peso coin, as I said, is 6.02 times 10 to the 23 peso coin. Now, if I'm going to distribute every penny, okay, all living people around the world could spend 1 million per hour for the rest of their lives. So imagine that this mole is really big. For trivia time, do you know that we have an official holiday which observed by mostly chemists and frustrated chemists, and that is called Mole Day? Mole Day is observed every October 23rd of the year from 6:02 in the morning to 6:02 in the evening. Okay? So just for a trivia. Now, at the next lesson, we are going to discuss the relationship between Avogadro's number and the number of moles. So, thank you.